Good morning, students. Yesterday we already start with that is generation and connection of the nerve impulse. In this class you are going to discussing about it is the once again, that is the nerve impulse. Once again you are explain that one. It is somewhat difficult, but it is very easy topic. Once you are read the NCERT textbook, after then you can easily understanding the topic easily. Generation and conduction of the nerve impulse. What do you know? Generation and conduction of the generation and conduction of the nerve impulse. Generation and conduction of the nerve impulse. The nerve impulse means, keep in your mind, only one point remember in your mind. Generation of nerve impulse means that is the movement of the ions, exchange of the ions. The outside polarity, inside polarity, it is all sometimes change. Once the neuron receive the stimulus, once the neuron receive the signals from the surroundings, the neuron receives the stimulus. Stimulus means cold, temperature, heat, pH, the different types of ionic concentration, external or internal temperature, or physical factors, or chemical factor, or biological factors. Once the neurons receive the stimulus means the neurons are respond. Once the neurons are respond means outside positive charges, inside the negative charges, again there are always movement. Once the ions are moving into the outside cell to the inside cell, inside cell to the outside cell, outside to inside, inside to the outside, means it will generate nerve impulse. Nerve impulse are nothing but movement of the ions, exchange of the ions. Once the neurons are receive the stimulus, the neurons are always excitable cells. The excitable cells means the neurons always polarized. Polarized means outside always they maintain the positive charge, inside always maintain the negative charge. The main reason is the outer membrane of the neurolemma, outer membrane of the axolemma, outer membrane of the axon, outer membrane of the axon, it is known as a outer membrane of the axon, it is known as a axolemma. Axolemma, outer membrane is known as a axolemma. This axolemma outside always positive charge, inside always negative charge, it maintain. Axolemma outside always polarity, positive pole. This is a pole, it is the axolemma, it is the axolemma. Below the axolemma, exoplasma, outside extracellular fluid, inside intracellular fluid. Outside always maintain positive charge, inside always maintain negative charge. Do you know how the neuron, it is the polarized? Polarity means outside pole positive, inside pole negative charge. That is the resting condition. Resting condition. If you observe the generations of the conduction of the nerve impulse, it is divided into three types. It is divided into C1 here. Generations of the conductions of the nerve impulse. First one, resting membrane. Resting membrane. What is the first one? Resting membrane. Resting membrane. Resting membrane potential. It's nothing but resting membrane potential. The resting membrane potential. Coming to the second one, depolarized. What is the second one? Depolarized. What is the third one? Second one, depolarized. Third one, repolarized. Simple one, repolarized. Fourth one, hyperpolarization. 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 What is the condition? The generations and connections of the nerve impulse. First one, resting membrane. Resting membrane means the neurons, they are not conduct any impulse, they are not generate any impulse, they are not receive any signals. The neuron membrane is axolemma is resting condition. 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 Is nothing but axolemma. Axolemma. Axolemma means plasma membrane of the axon. Plasma membrane of the axon. This axolemma consists of the outer membrane of the plasma membrane. That is, this axolemma consists of the different ion channels. Different ion channels. These different ion channels means sodium channels, potassium channels, sodium potassium channels, voltage gated channels, leaky channels, sodium potassium ATPase pump channels. Different ion channels are present in this class. Different ion channels are present in the axolemma. Different ion channels. These ion channels are selectively permeable. Selectively. They are selected some molecules. They selected sodium channels, sodium ions and potassium ions. They selected some molecules. If you observe the axolemma, outside this nothing but axolemma. Outside of the axolemma is nothing but extracellular fluid. Outside the axolemma is known as extracellular fluid. Inside the axolemma, inside the axolemma it is known as exoplasma. Exoplasma. This exoplasma, inside the exoplasma, it is always negative charge. Exoplasm means intracellular fluid. That is nothing but exoplasm means cytoplasma of the axolemma. Inside always negative charge, outside always positive charge. Outside always positive charge, inside always negative charge. This outside positive charge, inside negative charge, it is maintained by this membrane. It is maintained by the positive charge outside, inside is negative charge. Outside extracellular fluid, outside always sodium ion concentration is more compared to the potassium. It is extracellular fluid, outside always sodium concentration is more compared to the potassium. Inside potassium concentration is more compared to the sodium ion concentration. But here this negative charge is maintained by the negatively charged proteins. Negatively charged proteins. These positive and negative charges, always outside positive, inside negative charge. This positive negative charges is maintained by this positive and the negative charge. It is maintained by this plasma membrane, that is the axolemma. This consists of one important pump is known as a sodium potassium ATPase pump. Sodium potassium ATPase pump. Sodium potassium ATPase pump. This sodium potassium ATP, this sodium potassium always, see here, sodium means 3 sodium move into the inside to the outside. 3 sodium move into the inside to the outside. 2 potassium move into the outside to the inside. Outside to the, it is the extracellular fluid. It is the intracellular fluid. 3 sodium move into the inside to the outside. 2 potassium move to the outside to the inside with the help of they are using ATP molecules. The sodium potassium means that is nothing but proteins. These proteins, they can utilize ATP molecules. Once they can utilize the ATP in the form of energy, 3 sodium they will send into the inside to the outside. 2 potassium send into the outside to the inside. They maintain the balance. Balance means outside always positive charge, inside always negative charge. This outside and inside, outside positive, inside negative. It is the outside, inside. They maintained by the sodium potassium pump. What is the other condition for during the resting membrane condition? What is this membrane? This axolemma membrane, this axolemma membrane means resting membrane means they are not conduct any impulse. They are not receive any signals. Here resting means they are not receive. They are not conduct. They are not conduct any impulse. They are not conduct any impulse. They are not receive any impulse. They are not receive any signal. They are not receive any signal. This membrane, it is always permeable to the more permeable to the potassium ions. Permeable to the potassium ions. Permeable this membrane during the resting condition. Resting membrane means it is the resting membrane potential. Means at the time during the resting membrane means they are not receive any signals. It is permeable to the. It is the permeable. What is first one? Sodium potassium. They maintain the balance. Second one, permeable to the potassium ions. Permeable to the potassium ions. This membrane impermeable to the sodium ions. Impermeable to the sodium ions. And also this membrane, it is the impermeable to the negatively charged ions. Impermeable to the negatively charged ions. Negatively charged ions. Impermeable to the negatively charged ions. These negatively charged ions, they are not moving to the outside. Okay, and also impermeable sodium ions means outside to the inside, they are not moving. And the permeable to the potassium ions, the potassium ions move into the inside to the outside. Outside positive, inside negative, maintain with the sodium potassium pump. Sodium potassium pump. Once that is the resting membrane potential. Resting membrane potential during the condition. See here, resting membrane condition. Resting. What is the first one? Resting membrane. Resting membrane. Resting membrane potential. What is the resting membrane potential? Outside, it is the axolemma. Outside, positive. Inside, negative. Outside, positive. Inside, negative. Sodium potassium pump. Sodium potassium pump. Impermeable to the sodium. Impermeable to the negatively charged. But the permeable to the potassium ions. Permeable to the potassium ions. It is the resting membrane. Depolarization. 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 Depolarization means once they receive the stimuli, the signals arrival. Signals arrival on the axolemma. Signals arrival on the axolemma. This membrane permeability changes. This polarity changes once they receive the signals. Once the axolemma receive the signals, this outside always during the depolarization condition, sodium channels are open. Sodium channels are open. Sodium channels are open. What is it now? Sodium voltage gated channels open. Voltage gated channels are open. Once they receive the stimulus, the axon membrane receive the stimulus, sodium voltage gated channels are open. Once the sodium voltage gated channels are open, okay, influx of the sodium ions. 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 Once the sodium ions move into the inside means inside charge is positive charge. Outside always negative charge. Outside it is the extracellular fluid. It is the extracellular fluid. It is the intracellular fluid. Means depolarized means once the neuron receive the stimulus, once the neurons receive the any signal, the polarity change. Polarity change means depolarization. Polarity means depolarization. During the depolarization, voltage gated channels are open. Voltage gated channels are open means sodium ions move into the outside to the inside. Once the sodium ions move into the inside means inside charge is positive, outside charge is negative charge. Coming to the repolarization. Coming to the repolarization. Coming to the repolarization condition. It is the repolarization condition. Repolarization means again signals loss, or loss means signals stop. Signals stop. Whenever the signals are stopped, potassium channels are open. What is the channels? Potassium channels are open. Potassium channels are open. Sodium channels closed. Sodium channels are closed. Whenever the sodium channels are closed, outside always positive. Repolarization means again polarity change. Potassium move into the outside. Potassium move into the outside. Again the polarity is changed because of potassium channels are open, sodium channels are closed. Whenever the sodium channels are closed, potassium channels are open, outside always positive charge. Again the signals are lost. Stop. Whenever the hyperpolarization means it is the movement of the potassium ions, more movement of the potassium ions. Hyperpolarization means positive, negative. Okay, hyperpolarization means more movement of the potassium ions outside. More movement of the potassium ions are outside. Potassium outside. Hyperpolarization polarity means minus 90 millivolts. It is maintained in the resting membrane potential minus 70 millivolt. This positive negative. This polarity is maintained by the what is the polarity? Minus 70 millivolt. And during the depolarization condition, minus 34 millivolts. What is the polarity depolarization condition? Minus 34. But here it is a signals are stopped. In our textbook, they are given. See once here. According to in our NCERT textbook, they are given two diagrammatic representation. How this nerve impulse are generated, A to B, B to A, how they will generate. See, indicated. The first diagram they indicate. See here. First one they indicate here. For example, this one here. This one is indicated B. First one they indicated. First one. What is the first condition? Resting membrane. Resting membrane means outside positive, inside negative. Once this axolemma receive stimulus, this is axolemma. Axolemma consists of different types of channels. Axolemma consists of different types of channels. It is once the axolemma receives the stimulus, the outside the polarity sodium channels are open. Once the sodium channels are open means influx of the sodium. Influx of sodium means inside always positive charge. Outside negative charge. Negative charge means depolarized. Depolarized. What is the condition? Depolarized. But the B1 is polarized. One is polarized. What is polarized? Positive, 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 positive. They are not generated any signals. Negative, 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 negative. Positive, 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 positive. This entire axonal. Negative. Positive one. Once they receive the stimulus, it is a depolarized. Polarity changes. Once the polarity changes, but B1 is polarized. Polarized means outside positive, inside negative. It is the intracellular fluid. It is the extracellular fluid. This membrane is depolarized, but this one is polarized. They are not receive any signals. They are not receive any signals. It is the A condition. A condition means they receive the stimulus, means polarity is change. Polarity is change. Coming to the next diagram, they indicate. See here. Next one, they indicate here. Next one, they indicate. See here. Outside, it is, for example, they indicate A. They indicate B. After that, indicate B. A means depolarized. A means depolarized. Depolarized means outside negative. Outside negative. Inside positive. Inside intracellular fluid. Extracellular fluid. It is a depolarized. It is a depolarized. But the B is, see here, positive, 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 positive. Positive, 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 positive. Negative, negative, negative. Negative, negative, negative. Means it is the polarized. Means it is the depolarized condition. It is the apolarized condition. It is the A. It is the B. How the nerve impulses are generated? See here. The inside to the A to B. Inside. A to B. A to B. A to B. The positive ions move to the B, to the negative ions. The positive moves to the negative ions of the B. See, head of the B, it is the B head. It is the A. Positive move into the S. Positive move into the B's move into the positive. Positive move into the A. Here inside, positive move into the negative. Positive move into the negative. This impulse, but here, positive, 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 negative, 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 positive, 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 negative, negative, negative. For example, this positive move into the next, the positive, the ions move, the ions jump into the one membrane fiber to the next one. Then an axon, one, it is the one axon to the next one. One axon, they are divided into the 3 or 4 types of axons. But here once this ions jump into this place to this place, the ions are jumping into the one axon, means one node of the runaway to the other node of the runaway. It is the one myelin sheath to the other myelin sheath. It is the one, the ions, this conduction is known as a saltatory conduction. Saltatory conduction. Saltatory conduction means the ions are jump into the one node of the runaway fiber to the other node of the runaway fiber. Other node of the runaway fiber. For example, this positive ion move into this side. The positive ion move into this side. Positive ion move this side means here polarized means that is positive means this positive, 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 positive. Positive means positive. Positive means this one is this polarized condition converted to the depolarized. Depolarized. Here positive means positive, 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 positive. Here the positive, this positive means this all positive move to the here means positive, 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 positive. But here negative, negative, negative. But here this all positive move to the here means this one is negative, 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 negative. Again this one is depolarized. Again this one is positive, 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 positive. But inside is negative, negative, negative. Inside is negative, negative, negative. This one is depolarized. Before that one, repolarized. 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 Again this one is depolarized. Again this ions, see, positive ions move into here. Positive ions move into here. This positive move into here. This positive move into here. Depolarized here. After this ions jump into the other, see, depolarized. Here again this positive. This positive means positive, 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 positive. Okay, this one is positive, 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 positive. Okay, this one is negative, negative, negative. Means this one also depolarized. Depolarized means here positive, 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 positive. This all ions are movement means here negative, negative, negative. Here positive, 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 positive. But here positive. Depolarization means negative, negative, negative. Okay, these ions are all positive, positive here. But inside, okay, negative, 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 negative. Outside positive, here polarized again. This one is depolarized. This one also repolarized. This one is repolarized. Means the ions move into the one to the other. The ion jump into the current flow. The current flow means A to B, B to A. The current flow, it is the A to B, B to A. How these ions are moving? How the generation of the nerve impulse? Nerve impulse means the ion movement. The ion, nerve impulse means ion movement. Ion movement means ion movement. Ion movement means polarity change. Polarity change. Polarity change. Polarity change means generations of the nerve impulse means outside positive, positive, inside, outside positive, positive, inside negative, negative. Once they receive the stimulus, once they receive the signals, this positive charge, negative, negative, inside positive, positive. That is nothing but nerve impulse. Nerve impulse means the polarity change. The one point remember in your mind, polarity change. The polarity change means nerve impulse. The signals means nerve impulse. The resting condition, no polarity change. Outside positive, inside negative. But once the depolarization condition, the polarity change. Once they receive the stimulus, once they receive the signal from the surroundings, they receive the signals. Means the polarity change. Outside, always negative. Inside, positive charge. That is during the, once they receive the stimulus. Nerve impulse means the polarity change. Nerve impulse means polarity change. How these ions are moving to the inside to the inside, A to B and B to A. Once this one is polarized, first one depolarized, this one is polarized. Again these ions move into the polarized conditions. Again these ions move into the depolarized. Before one repolarized, this one depolarized. Again next one depolarized, this one depolarized. The repolarized. See here, depolarized, repolarized. Even before one, once the depolarized means this one is repolarized. Again next one is depolarized means before one repolarized. Next one depolarized, before one repolarized. How this entire axolemma, this one is generate this entire axon membrane, axolemma is generate the action potential. At the time of the repolarization condition, potassium channels are open. Sodium channels are short-lived. Short lifespan means sodium channels are closed. Whenever the sodium channels are closed, potassium channels are open. Whenever the potassium channels are open, outside positive charge, inside negative charge. The repolarized condition, potassium channels open. Potassium channels are open. Here, sodium channels open. Sodium channels are open. These sodium channels are maintained by the outside. These sodium channels are maintained by the inside. These sodium channels are, this dipolarized condition, sodium channels are open. The repolarized condition, potassium channels are open. Potassium channels are open. That is the main condition for the, during the nerve impulse. This nerve impulse, for example, if you observe the nerve impulse, this nerve impulse, the action potential generated in the myelin sheath. See, two types of the neurons. What is the two types of the neurons? Myelinated neurons. Second one, non-myelinated neurons. Non-myelinated neurons or nerves. Myelinated neurons means myelinated neurons means myelinated neurons myelinated neurons. Myelinated neurons. Myelinated and non-myelinated. Myelinated and non-myelinated. Myelinated neurons means the neurons, it is covered, it is protected by the myelin sheath. Protected by the myelin sheath. Protected by the myelin sheath. Nothing but myelin sheath. Myelin sheath. Myelin sheath. It is protected by the myelin sheath. But here myelin sheath is absent. Myelin sheath is absent. Myelin sheath is absent. Once the myelin sheath is absent, how the nerve impulses are generated? How this nerve impulse? Here the myelin sheath is present. Once the myelin sheath is present means the impulse. See once here the myelin sheath. After the myelin sheath, it is protected by the node of Ranavir. Node of Ranavir. Node of Ranavir means once the receive the signals. Here once the signal reaches to the axolemma, these ions jump into the one node of Ranavir to the other node of the Ranavir. The ions are jump into the one node of the Ranavir to the ions jump into the one node of Ranavir to the other node of Ranavir. The ions are jump into the one node of the Ranavir to the other node of the Ranavir. This node of Ranavir, it is nothing but this is for the saltatory conduction. Saltatory conduction. What is it now? Saltatory conduction. The node of Ranavir, it is helpful for the saltatory conduction. The ions are moved into the one node of the Ranavir to the other node of the Ranavir. It is a fast conduction. It is the fast conduction. This is the fast conduction present in the central nervous system and peripheral nervous system. Central nervous system and peripheral nervous system. Those neurons can stop myelin sheath. For example, myelin sheath is absent. Myelin sheath is absent. The ions jump into the ions. It is a slow movement. Slow movement. Because of myelin sheath is absent. The myelin sheath is absent means it is a slow movement, but the myelin sheath is present. Those neurons are consist of myelin sheath. The ions are jump into the one node of the Ranavir to the other node of the Ranavir. One node of the Ranavir to the other node of the Ranavir. But here non-myelin sheath means the myelin sheath is absent. Once the myelin sheath is absent, the ions movement is very slow. The ions movement is very slow. But here is a fast movement. Fast means there is nothing but saltatory conduction. Saltatory conduction means the ions jump into the one node of the Ranavir to the other node of the Ranavir. Other node of the Ranavir. Other node of the Ranavir. How these impulses are generated? How the nerve impulse is nothing but it is the movement of the ions. Movement of the ions or exchange of the ions. Thank you very much. I hope everyone understands this topic.